Hello everyone, welcome back to my YouTube channel. In this video, we will learn about string algorithms. It is very important topic in computer science and programming. Whenever you search a word in a document, typing something into a Google or sending messages, string algorithms are working behind the scenes. They help computers to understand, process and search text efficiently. In this video, we will discuss what a string algorithms are, common string operations such as substring searching and pattern matching, important terminologies such as text, pattern, match, and finally, we will understand the basic string algorithms called naive search algorithms by using a clear and simple example. So let's begin. First, let's understand what a string is. A string is simply a sequence of characters stored together. There are some examples for string. Each character in a string can be letters, numbers, symbols, or even spaces. Strings are used everywhere in programming, such as usernames and passwords, search boxes, messages and emails, files and documents, etc. So whenever a program deals with a text, it is actually working with strings. Now let's talk about string algorithms. String algorithms are algorithms designed to process, search and manipulate strings efficiently. Instead of checking characters randomly, these algorithms follow step-by-step rules to work with text. They are commonly used in text editors like Word or Notepad, search engines like Google, DNA sequence analysis, spell checking systems, data validation programs. So anytime a program reads or searches text, string algorithms are involved. Before going deeper, we must understand three important terms that are used in almost all string algorithms. We can call them key terminologies. So there is a text. The text is the main string where the searching happens. It is usually longer. As you can see, there is a string referred as this is a simple string. This entire sequence of characters is our text. Next, we'll talk about the pattern. The pattern is the string we want to find inside the text. It is usually smaller. In this example, the symbol is the pattern. Our goal is to check whether this pattern exists in the text. Third terminology is match. A match occurs when all characters of the pattern appear in the text in the same order. If this condition is satisfied, we say a match is found. Now let's look at some common operations performed using string algorithms. First one is substring search. Substring search checks whether a smaller string exists inside a larger string. There are some examples. In this example, the text is programming and the substring is gram. Since gram exists in programming, the substring search is successful. This operation is commonly used when searching a word inside the document. Next operation is pattern matching. Pattern matching is slightly more advanced. Instead of finding just one occurrence, it tries to find all occurrences of a pattern inside the text. There is some example text name as ABABA and pattern name as ABA. Here the pattern ABA appears more than once. Pattern matching is widely used in search tools, compilers, virus scanning software. The third string operation is string comparison. String comparison is used to compare two strings and check whether they are exactly equal, not equal, or which one comes first alphabetically. There are two examples. The first example we can call as equality check. So in this example, I'll use two strings. Since both strings contain the same characters in the same order, they are equal. So these strings are matching each together. The second example is case difference. In this example, I'll take two different strings. Even though they look similar, they are not the same because uppercase and lowercase letters are different. So these strings do not match each together. String comparison is commonly used in logging systems and form validation and searching and sorting text data. The final string operation is string replacement. String replacement is used to replace a part of a string with another string. This operation helps modify text without changing the entire string. For example, I'll take a string refer as I love Java programming. I'll replace the Java with Python, so result becomes the I love Python programming. Here, one word is replaced while the rest of the text remains the same. String replacement is commonly used in text editors to find and replace autocorrection systems, data cleaning, and formatting text. Now let's move to the main part of this video, the naive string matching algorithm. This is the simplest string searching algorithm and is very useful for beginners to understand how pattern matching works. So what is the idea of naive search? The idea of the naive algorithm is very simple. Align the pattern with the text, compare characters one by one. If a mismatch occurs, shift the pattern one position to the right. Repeat this process until the end of the text. There have no shortcuts, no optimization, just the simple comparison. Let's take some real world example to understand more about the naive search algorithm. Consider this string of characters. All the characters happen to be a letter of the alphabet, but they could just as well be a mixture of letters, digits, and punctuation symbols. In an application, the string might be stored inside an array variable or a list or even a file. From now on, we refer to the string of characters as the input string. Normally, the input string would be much longer than this and we would know little about its exact contents. Now suppose we want to search the input string for a particular word or indeed a pattern of characters. In this example, we want to know if the input string contains word cakes. We refer to the word we are looking for as the pattern. In an application, the pattern would probably be stored in an array variable or list. We're going to give each character of the input string and each character of the pattern an index number. This will help to explain how various starting matching algorithms works, and more importantly, it will enable us to write programs to implement these algorithms. By convention, we number the items from 0. Eventually, when we do write a program to perform the search, we'll need a variable to keep track of the character of the input string that we are currently considering. This is shown here as an arrow. At the start of the search, it's pointing to item 0 of the input string, which happens to be a letter X. We'll also need a variable to point to pattern character that we are currently considering. At the start, it's pointing to item 0 of the pattern, in this case the letter C. Now let's begin with a simplest approach to searching for a particular pattern within the input string. This is often referred to as the naive approach. That's not to say it has practical use, but it will become apparent why it's considered naive in later lessons, when we meet the KMP or BioMo algorithm. We begin by comparing item 0 of the pattern with item 0 of the input string. That is, we compare the letter at the pointers. They are not the same, so we advance the input string pointer. To help us visualize the algorithm, we are going to slide the pattern one place to the right. Bear in mind, however, that where comes to implementation, nothing actually moves. We are simply adding one input string point and pattern pointer doesn't change at all. Again, we compare the value at the pointer and again they are different. So we add 1 to the input string pointer, effectively advancing it while the pattern pointer remains unchanged. This time, when we compare letter at pointers, they are the same. So now we can add both pointers. When the next two letters are compared, we see they are also the same. So we can increment both pointer again. Yet another pair of letters are the same, so both pointers advance. And again, but this time the letters are different. We have failed to find the last letter of the pattern. So we have failed to match the whole pattern. The simply string matching algorithm now resets the pattern pointer to 0 and input string pointer move back to item 3. Checking then starts again from here. By the way, the simplest approach is using a sliding window technique. Although nothing is actually sliding, it's just the way we choose to visualize what's going on. The algorithm will ultimately find a match for whole pattern if there is a match to be found. But the approach is problematic for a number of reasons. Depending on the nature of the input string, we may have to do a lot of unnecessary processing by comparing pairs of letters when we don't really need to. It bit like using clam or nut. Furthermore, this approach requires that the letter moves backwards from time to time. Watch what happens when we search different input string that contains a lot of partial matches. The input string pointer spends almost much time moving backward and moving forward. Moving the pointer backward isn't really an issue for a short input variable. In fact, when we all program, it's just simple subtraction operation. This makes the simplistic algorithm very easy to implement, and it's fine and small amounts of data. However, if a string matching application is required to stream the input string from an external file, a text file for example, then it's going to be more efficient if the input string pointer only even moves in one direction, forwards. If the pointer must move in both directions, searching a file is complicated by the need to read successive chunks of the file into memory. That data can be traversed forward and backwards. So the simplistic approach you are just made is far from perfect. So why it's called naive? It is called naive because it does not use any smart tricks. It compares the same characters multiple times and it can be slow for large text. However, it is very easy to understand, easy to implement and perfect for learning the basics. Next, we'll talk about time complexity. So let n be the length of the text and the m be the length of the pattern. In the worst case, the pattern is compared at every position in the text and for each position all pattern characters are compared. So the time complexity is O n multiply by m. This means longer text and longer patterns require more comparisons. So today we covered the basics of string algorithms. We learned the key terms like text, pattern and match, and we explored the common string operations, and we understand how the naive string matching algorithms work with simple example. This gives you a foundation to learn more advanced string algorithms in future. So if you found this video helpful, like, share and subscribe, and thank you for watching.